All right, let's get started. I think most of us are here. Whoops, just muted myself. All right, so hello everyone. On behalf of the NASA DC Space Grant Consortium, the Georgetown University Space Initiative, the students for the education and development of space, thank you so much for attending this event. Today, we're welcoming 4 leaders in the space industry to discuss the future of commercial space stations and in light of the retirement of the International Space Station in 2031. This event will be recorded and posted to the GUSI YouTube channel, so you can look out for it there. And please submit any questions you may have in the chat privately to me through the course of the event, and we'll address them at the end. So first, I would like to introduce Chris Blackerby. His extensive experience with NASA and is currently serving as the COO of Astroscale. So please give a warm welcome to Chris.
Hey, thank you. Look at all those wonderful applause marks. I feel like I'm in a conference room. Good to see everybody, old friends, new friends, and all of you interested Georgetown students. It's great to see. I got to meet a couple of you yesterday at the conference, and thanks again to those, yes, who came over. Steve, Lucia. I don't know if others are on, are they? But it was good to meet. You in person. So I think we said 5 to 7 minutes. Is that right, Sarah?
That is correct. 5 to 7 minutes for your speech.
Okay, so I'll talk a little bit about Astroscale, the company I work for. Now, today we're talking about commercial space stations and the future of these LEO outposts. And I'm a little bit of an outlier for this topic, because Astroscale is not doing anything with commercial space stations. But we do talk often about how our orbits are a finite natural resource. And we have to do everything we can to make sure that they are sustainable. And what we talk about at Astroscale is balancing the development of a resource like our orbits with the efforts to make it sure that it can be used going forward. So we're not looking to not utilize the orbits. We recognize the value that they provide and that they're going to be the future of our space and really our terrestrial economies. But we want to make sure that they can be utilized for future generations. So we're focused on debris mitigation and servicing of satellites, both satellites and eventually human outposts. In LEO and GEO and cislunar orbits. So I'll talk a little bit about what Astroscale is doing, run through a couple slides, but would like to save most of the discussion for questions and the other panelists. So let me just share my screen so you can see what I'm talking about. Give me a second. So I think you should be able to see my screen now, PowerPoint. Yes?
Yes, you can see it.
Great. Something that I think many of us already know, our orbits are already closing in on being unsustainable. There are over 30,000 objects larger than 10 centimeters in orbit, and only about 5,000 are active satellites. So we're talking about 2 primary orbits when we're looking at this, and the areas where Astroscale is focused is on low Earth orbit, about 200 to 2,000 kilometers altitude, and then geostationary orbit, about 36,000 kilometers altitude. The issue is prevalent, the issue of debris, the issue of satellite servicing being a necessity to drive the economy is important in both of these orbits and the orbits in between. Of which there are several, but these are the 2 main ones that we're focused on at Astroscale. And this orbital environment is getting more crowded and more dangerous all the time. And you see the conjunction trends for active LEO satellites just spiking recently. There have been so many launches of constellation satellites over the past several years that you see that the number of monthly conjunctions within 1 kilometer in LEO back in 2020 was about 2,000 a month. And you see now it's closing in on about 6,000 a month. So about a 3 times increase in the number of conjunctions in LEO, which means passing within 1 kilometer of each other. that's getting dangerous. This is dangerous for active satellites, which provide so many services to us on Earth. And it's really dangerous for human outposts in LEO, which is what the other panelists are going to be talking about. So as we're looking to really advance, not only advance the economy of what we're doing in space, but protecting people that go to space, we need to start taking action to mitigate this risk. So we're talking a lot about debris removal, but really we're not a debris removal company. Astroscale is not. It's how we made our name. It's how people oftentimes reference us, but we're more than that. We're a satellite servicing company, and that encompasses all aspects of what we can do to help maintain, repair satellites, remove them when they're failed, refuel them. There are many things that we can do in the post-sales servicing aspect. And all commercial industries that are developing products that people buy have a post-sales servicing aspect of the economy. When you buy a car, you're not expecting that you buy it until it runs out of gas and then you buy a new car. That would be ridiculous. There would be no automobile economy if we did that. When a company buys an aircraft, they're not expecting to buy it once until it runs out of gas or until a part breaks and then not use it again. We need to get to that point in orbit. And that's what's going to completely transform the economy when we have a post-sale servicing aspect of satellites. Now, of course, it's difficult. It's much easier to repair a car on the ground with gravity and with oxygen than it is to do it in orbit. So we recognize the technological difficulties in making this happen, but this is what we're working to get toward. So Astroscale is doing this as a global company. We started in Singapore in 2013, expanded to Japan a couple of years later, then to the UK, the US, and Israel. Over the last few years, we've been expanding internationally. We recognize that solving this problem is not something that one country or one company can do. We need to have a global footprint. We need to be able to interact with policymakers, with people in the governments that are controlling budgets, with supply chains, with future team members around the world. We need to pull on that globally. And so we've made an effort to expand maybe quicker than most would have. We're still only a 260-person company, but we now have offices in 5 different countries. But we're growing in each one, and we're doing manufacturing in many of these. A quick look at what our service options are, and then I'll stop and let the others speak. But just to give you a quick summary of where our service options are. The first one is end-of-life service, and this is preparing satellites before they launch to be more easily serviced in the future. Our proposal is to put a ferromagnetic docking plate on satellites before they launch so that we can then go up and capture them with a magnetic capture mechanism. That allows us to remove failed satellites from orbit right now. Eventually, we hope that it would allow us to also do additional servicing of satellites. But if customers prepare these before they launch, makes it easier for us to manufacture, cheaper for us to produce, and then cheaper for us to price as well. That's going to drive the economy. The next one is ADR, active debris removal, which is removing current debris in orbit. So current debris doesn't have those plates on there where we can attach to. So we need a different type of capture mechanism. We use the same software, the same guidance, navigation, and control technology to approach the object. But when we get there, we'll need to have robotic arms to grab onto it. So we're building robotic arms internally to make sure that we can remove satellites that are, or upper stage rocket bodies that are in orbit now that are risky debris. In situ space situational awareness, we need to have a better picture of what's happening in orbit. Right now, we have a lot of ground-based capabilities that is telling us what's up there, but it doesn't give us a completely accurate picture. To get a holistic picture, we should have something in orbit as well. So a satellite that has sensors that can view either an object or an orbital plane to make an awareness of what kind of threats might be up there. And the final one is life extension. And in life extension, we're focused more on the geo orbital belt. So that's going up and extending the life of these large geo satellites that are primarily communication satellites, both commercial and government. We can extend their life. We can relocate them as needed. It helps customers to manage their needs of when to replace a satellite and how to manage the revenues that are coming in from current customers. So these 4 mission lines, they share a lot of common technologies, but they have different customer bases, and it helps us to diversify all of the different opportunities out there. But all of these are contributing toward that post-sale servicing economy that's going to drive the ecosystem in orbit. And it's going to drive a lot of what happens with human outposts as well. So I'll stop there and turn it over to the next speaker, Sarah.
Perfect. Thank you so much, Chris. Let's see.
Let me see if I can stop sharing.
There we go. All right.
It hasn't stopped yet.
Let's see. Oh, here, I can stop it for you. There we go.
Yeah, sorry.
All right, no problem.
You stop it
so, okay. So next I'd like to introduce Bruce Morris. He has extensive experience with NASA as well, and he is currently serving as the Senior Director of Business Development at Sierra Nevada Corporation. So Bruce, if you'd like to either share your screen or begin presenting.
Having a little trouble with the data stream, so I'm going to turn the video off so it doesn't get choppy again. And then I'll turn it back on when I'm in listening mode. Thanks so much for having this. It's really exciting to talk to a group of people that are in the renaissance of the space industry. It's an amazing time for you guys to be involved with this, and I'm excited as heck for you as you enter this part of your career. I'm going to talk a little bit about Sierra Space and then some of the activities we're doing associated with low Earth orbit. Sierra Space was a spinoff from Sierra Nevada about a year ago, was when we became a standalone, a wholly owned subsidiary, excuse me. And we did it so we could put a focus on space as a commercial service, with our mission to build a platform in space to benefit life on Earth, because you have to have a lofty mission when you're doing this kind of thing. We really believe that by opening up affordable access to space, that'll enable existing businesses and entrepreneurs and researchers and governments to create some really exciting breakthroughs. And this is, we think, is a unique opportunity to bring people together in space in a way that we've never had this opportunity in the past. We're privately funded, and we recently got a Series capital investment round that has set us up for success. Let's see. Next, I'll talk about Orbital Reef. Let me see if I can share a screen. Can I go ahead and try to do that? Okay.
Sure. Should have sharing permissions.
All right. Tell me if you can see that.
Yes, we can see it.
Okay. So Sierra Space joined Blue Origin in partnership back in 2021. We recognized we each had unique capabilities that made for a natural partnership, with our focus to develop a commercially owned and operated space station in low Earth orbit to take up the requirements of NASA as they deorbit ISS, and also to address the much larger commercial market that's out there looking for opportunities to develop and work in space. We've designed around the idea for multiple new markets in space, providing anyone the opportunity to have an address on orbit. We will offer a service that we believe can address research and government, in industry and international and travel customers in a cost competitive way by providing end-to-end services, because we think that, or we believe that by reducing the cost of access with reusable transportation and by offloading the complexity of the vehicle infrastructure and the operations, we can significantly lower the barriers for living and working in space. Our timing is a little ahead of what ISS is looking for, but that's all right, because we're looking to be in a place where we can be one of the service providers to be able to take up NASA's needs for exploration, as well as the commercial needs in the marketplace and international needs for low Earth orbit. Our baseline configuration is a power system, a core module, the life habitat, and a science module, which gives you roughly the same amount of pressurized volume as space station and can support up to 10 people on orbit at any one time. Okay, let's go ahead and close out. Can you unshare my screen, Sarah, or how do we do that? For some reason, I'm not getting the, are you still there? There we go. And you can still hear me, right?
Yes.
Okay. And so if I hit that, I can somehow unshare. I'm still trying to figure out how to unshare. Can you unshare me?
Yes, I believe we're all back in the main section now.
Okay. And the last thing I'll leave you with is Orbital Release working with Arizona State and a consortium of 14 universities. So, touching the area that you're really concerned and engaged with. Next, I want to talk about a couple of other offerings. The Life module that's a part of the Orbital Reef. It's part of our contribution to Orbital Reef, but we also believe it's capable to operate as an independent platform for multiple applications like Mars Transit Vehicle, lunar habitation. Life stands for Large Integrated Flexible Environment. It launches on, it's launch vehicle agnostic, so it can launch on any heavy lift vehicle with a 5-meter fairing, and expands to about a 3-story building, which is roughly a third of the volume of the current ISS. This unique structure can be outfitted for multiple businesses, which we think is a very significant capability that's needed on orbit. It's got, as we said, significant volume and power and data, and to support long duration human habitation. And let's see, I think that's all about it. And then the last thing I want to talk about is Dream Chaser, because that's the thing everybody seems to think about with us. Dream Chaser, of course, is the only winged commercial space plane, and the next generation, we believe, of space transportation. It's about a quarter of the length of the NASA space shuttle, and it's set up for cargo missions to deliver 12,000 pounds of cargo to ISS at any time. Our flight window for this year opens up at the end of November in 2022 and closes in the end of February in 2023, and we will make that flight window. It's autonomous launch and flight and landing capabilities. It can be reused up to 15 times. As I said, the launch vehicle is agnostic. It can go on any heavy lift vehicle. And one of the unique things about having a winged vehicle for reentry is it provides a very low G reentry for crew and cargo. And because of the design being green design, it can land on any existing commercial runway that can handle a large jet. The crew version is in development right now. The cargo version, of course, flies under the NASA contract. We believe this will be a very capable next generation of crew and car transport to low Earth orbit. And that's about it for Sierra Space.
Wonderful. Thank you so much. All right. Next, it's my pleasure to introduce Jeffrey Manber. So, co-founder and current chairman of Nanoracks, as well as the president of international and space stations at Voyager Space.
Hey, thanks, Sarah. It's great to be here with everybody. And it's also great. It looks like the pandemic is winding down and we're meeting each other again. And so that's real nice. Look forward to seeing everybody when it's possible. Great talks by Bruce and Chris. And what I want to add to it is tell the perspective that I have working in commercial space. Where are we in commercial space? How did we get here? And where are we going? All that in a couple of minutes. And so let me start by saying, as Sarah said, I'm the president of international and space stations for Voyager Space Holdings. And that's kind of a strange title, isn't it? I mean, you're the president of international or you're the president of space stations, both of which is really cool. And the way I got to have that strange title is I was a co-founder and CEO of a company called Nanoracks, which started about 12 years ago. And we grew it into the largest commercial user of the International Space Station, with customers in over 30 countries. Customers include high schools and universities all over the world, as well as government agencies and biopharma organizations. And it's hard to imagine today. But when we started Nanoracks, we were the first company in the world to own and operate, charge money, and reach out to customers and put them on the space station. Before Nanoracks, it was completely government dominated. And so what you're really entering is a market and an industry that's in transition. And it's going from one that was completely government dominated to one that has sort of a partnership, which is more like how we do things in America, especially emerging markets where you have a government as customer, but they're one customer. And the government doesn't design the cars, to use Chris's analogy as well. Government doesn't design the cars, it doesn't design the planes, it shouldn't design the launch vehicles. And a lot of things we take for granted in America, we haven't been doing in space until recently. So Nanoracks grew, and I was able to sell it, which is also a fairly recent development, not terribly. I think there were folks at Sierra and stuff who had an exit and sold their company. But more and more recently, there's all of these new, smaller companies, and I was able to sell Nanoracks to Voyager Space. And Dylan Taylor, the co-founder of Voyager, asked me to stay on and said, would you work on international, which is one of my loves, and I'll explain that in a moment. And I said, yeah, but I know there's going to be an RFP from NASA for space stations. I know we're entering a new era, and I want my title to say space stations also. And he said, okay. And, fortunately, there was an RFP, and Sierra and Nanoracks Voyager and others, Northrop Grumman, were teams that won for this new era of private space stations. So we are in a new era. We spent the last decade, the government putting in a great deal of money into launch vehicles. And, it started with what was then Orbital Sciences, now Northrop Grumman, and SpaceX. And now today, who knows how many launch vehicle companies we have today. It's extraordinary. One can argue we have too many, but if you need a ride, you're not going to argue that. So we see that we have more choice because of the commercial pathway. We see that the price is coming down because of the commercial pathway. And now the government's saying, hey, we need the same for destinations. As Chris showed, they're also saying we need the same to have government as a customer for things like ecosystems and space services. But for the purpose of my talk, they're also saying it for destinations. And so we're entering in a really exciting time where instead of having one huge space station, we're going to have multiple privately owned space stations to come into play as we phase out the ISS. So Sarah, I'm not going to risk it because I had trouble this morning on another call. Could you just play? It's a 1-minute video. I want to introduce our space station, Starlab.
All right, yes, there we go.
Thank you. Thank you. Great, thanks, Sarah. And so, I could not personally be more excited about where we're going now. It's going to be a great couple of years where the users are going to have more and more choices of how to undertake their projects in space. More and more companies will be offering services. We should have more and more destinations. At Nanoracks, Nanoracks is even working on repurposing upper stages of launch vehicles. As Chris was talking about, we have to do something to eliminate the orbital debris and reuse of in-space hardware. That's something that Nanoracks is looking at as well. So it's a really exciting time, and I look forward to any of the questions that you may have. It's a wonderful time to enter into the community. There's so many more choices than when we all entered 10 years ago. I mean, I entered a long time ago, but there was a lot more choices than even 10 years ago. And it's a great time to really become part of the community. So with that, it's great, look forward to answering any questions on Voyager, on Nanoracks, on Starlab, or just anything on commercialization. So thank you. I'll turn it back over to you, Sarah.
Wonderful. Thank you so much. And last but not least, I'd like to introduce Christine Kretz. She's the VP of Partners and Programs and Partnerships at the International Space Station U.S. National Laboratory. So Christine, the floor is yours.
There we go, unmuted. Thanks so much, and it's great to be here. I have a very different job from the rest of the team. You have a nice group of people with different kinds of roles in space. I'm with the International Space Station in the National Lab, which NASA has designated a portion of the research. So NASA's role in research is doing exploration and supporting research that really tackles their mission. And ISS National Lab is here to have access for others who want to do research, whether it's universities or it's companies or it's small startups. And so the space station has been flying around for now 21 years. And for all of those who are younger than 21 years, and some of you are a little bit younger than that maybe, the space station's been up pretty much your whole life. And so it's exciting to think there's always been this inhabited facility in space. And NASA has just decided to keep it in space station in orbit for till 2030, which is fantastic because we need time for Jeff and the team and Bruce and the team to go ahead and build a replacement station because we don't want to go into a time when we don't have an orbiting platform for us in space. So we're excited that those things are all in the works. But the role of the National Lab is to help bridge and help build. So for example, Jeff's organization has probably been on the space station with the National Lab since the National Lab started. So his organization has been providing services out there for people who want to use the space station since the very beginning. But others have developed over time. And you want to have multiple capabilities. And when these new space stations come up and go into orbit, you want to be able to have functionality on the space stations, and you want to have a natural pipeline of work that is going to fill up Bruce and Jeff's space station with many, many projects from many, many companies. So the requirement for the government to be a part of it and be one of many is going to be important. And they're helping to launch those commercial LEO destinations. But we also need to have some others who see the value of doing research and technology development in space. So the National Lab is part of that. And what we're here to try to do is make sure that we're making known to people who would like to do space research that it's available to them and we're an access point, introducing them to partners who can de-risk and make that happen. And Nanoracks is one of our partners, along with Axiom and BioServe and many partners who can help people who want to do work in space who may not have done that before. Because even if you just want to do something as simple as crystal growth and pharmaceutical research, you'd have to have a partner who knows how to do that in space. You have to have a partner that knows and has a platform in space and can do those things. So we're trying to continue to build that ecosystem of organizations and researchers and technology development companies who see the value. So as the CLDs get built and get grown and get working out there, there's a steady stream of paying customers and capabilities on those stations. So over time, I'm going to do my screen share, maybe. Let's see if this works. Hang on a second while I make it work. hopefully you can see that. Oh, good. All right, so what we've done with our time over the past 10 years is built something from an early start of about 3 implementation partners. And I mentioned that Jeff Manber and the Nanoracks people were part of that, to now 39 commercial implementation partners who offer capabilities on the space station and can support the research. We hope that that continues to grow and that they will start partnering with the commercial LEO design people. Some of them are already embedded in those partnerships, so they can continue to build capabilities in space. We've also attracted 175 industry projects. And why this is important is these commercial destinations need to have commercial partners who are willing to invest their money and do their research. So AstraZeneca and Merck, obviously pharmaceutical companies want to do work there, but who else? Who else can we work with? Delta Faucet, Adidas has worked, as a matter of fact, with Jeff's team at Nanoracks. And so they are designing things and finding technology that they want to test out. But of course, academics, not-for-profits, either government organizations have to be part of it too, because that's part of an ecosystem. And we need to have external funding. And so there's also a lot of external funding from venture capital toward the startups that are going there, and not just the ones who are building destinations, but also the ones who are manufacturing in space. An example is Lambda Vision. And so their project has been making an iChip, and they've started with us. They launched their first project, and they've moved through multiple projects and a lot of venture capital funding that's helping them to build their company to potentially make a space manufactured iChip that would be used to return vision to people with macular degeneration. So our job is looking for those kinds of companies, bringing them to us, introducing them back to commercial implementation partners for support, and trying to build the bigger ecosystem, including the investor network, 250 plus venture capitalists interested in watching where these are going. So we consider ourselves sort of the doorway, an enabler, a supporter of the work that's going to go on the next space stations, and sort of bridge to where they're going to go. So we put out solicitations for organizations who want to fly a project. We have a network of our implementation partners that we try to stay close with, try to help advance their technology as they're working on the station. And understanding that space is very complicated. It's a lot what Chris was talking about. It's not that it's as simple as fixing the car in your driveway. You have to be able to fix a car in space. And if you're going to do pharmaceutical research, it's more complicated because you're going to do it in space, potentially with an astronaut who is not a bioscientist. So how do we help de-risk that? How do we work with these partners to enable those kinds of technologies? And how do we help attract more venture capital to some of these, especially smaller organizations who are working to build into the new space economy? So it is exciting. And I think all of us have said this, Bruce, Jeff, Chris, we've all said the same thing. This is a really exciting time to be part of this. And we would also tell you that you're welcome to be part of this too, because we need a lot of employees in this, not just astronauts, not just engineers, but people doing business development and scientists who are creating the next technology. So whatever it is that you like to do, there's a place for you to do that in the space race. And with that, I'm going to turn it back over to Sarah, because we're hoping you all have some questions for us.
Hello, everyone. So unfortunately, Sarah's having a few technical difficulties, so I am going to be filling in her place for now until she figures those out. So, hello, I'm Andres Permoy. I am the Chief Outreach Officer of GUSI, and thank you all for speaking with us today. And thank you so much for answering our questions. And so we can actually go ahead and dive right into the discussion with our first question. And that is, so the ISS is currently scheduled to retire in 2031 and ending a successful 3 decades long journey. So my question to you is, what happens after 2031? What do you think the future holds for us in terms of a private space station? Sorry, Christine, you're muted. Sorry.
Thank you. Sorry, too many mute buttons. For one thing, we know that as NASA has said, they're going to work on making these private commercial LEO destinations, but they've also committed to continuing to have an instance or more, one or more versions of a national lab, so that we continue to allow access to startups and people doing research. So we're very excited that NASA's agreed to continue to have a national lab in a commercial space destination. And with that, I'll turn it back over to the guys who are going to build that for us so we can be part of it.
Yeah, Bruce, I'll take a stab at that as well. Thanks, Kristen. And first, just so you know, Kristen, Nanoracks was working on the station before the cases. So just so you know, so we welcomed you to the space station. It's a really good question, and we all agree we cannot have a space station gap. Okay, we had a gap in the sending the crew after we sunsetted the shuttle program. We relied on the Russians to take our astronauts to and from space. Don't believe we're going to be relying on our Russian colleagues for in-space services moving forward. And given also, I don't like to play the Chinese card. I'm very proud that at Nanoracks, I was able to do the only commercial project with the Chinese on ISS. It was with Beijing Institute of Technology to do synthetic DNA studies. So I'm very pleased and welcome the competition from the Chinese space station. But certainly we do not want the only space station in orbit to be Chinese. So we are committed, everybody is committed that there cannot be a space station gap. So and that's also why, we'll say that we're hopeful there will be multiple stations. Maybe they'll be focused on different areas. We won't have one gigantic station with so many modules attached to one another. And then as we move along, let's say into the 2030s and the 2040s, as Chris was saying, you'll have in-space hardware that's repurposed, and we won't just toss it away and burn it up or put it in a graveyard orbit, we call it. So we're really moving towards having multiple opportunities, but the center of all this is to make sure there's no space station gap.
Great set of talking points, Jeffrey, as usual. I fully endorse what Jeff said. I believe the future in low Earth orbit is multiple commercial platforms. I don't believe NASA can be in a position and now their national security assets to rely on a single provider. That doesn't mean they're going to become a huge funder of a bunch of different things. It just means that they're going to have to encourage the commercial marketplace to develop so that multiple stations, probably purposed for different tasks, as Jeff talked about, are there. I think that's a key difference too. Instead of trying to, inside of ISS, carve out little areas that can make can work with multiple science needs and other activities. I think now with the advent of commercial industry coming into low Earth orbit, you're going to see stations that are, I'll say, more focused on the end product, whether it be a science research for pure science and manufacturing, for hard materials or biomaterials, national secure space needs. So I believe you're going to see, after ISS is deorbited, multiple commercial platforms in space.
And Chris, do you have any response to the question at all?
I only have questions to the responses. I have questions to the responses, not responses to the questions, Andres. Can I ask a question to people? Is that okay?
Yeah, go ahead. Dialogue between the panelists is encouraged even.
So I'm not being building a station or doing what Christine, Bruce, or Jeff are doing. My questions to you guys are, what's the role of international on this? All of these are domestic projects, and the International Space Station, as the name implies, is international. Are there going to be international components, or what's the connection there? And also, I didn't hear anybody talk about tourism. So I hear a lot of science and national security and utilization for technology and things, but I didn't know where tourism stands in the plans for station development.
So I'll take it
Sure.
first, Jeff, and then you can follow me and correct where I do it wrong. So let's see, there's multiple parts there. You started with international. Absolutely. International is a component of both Jeffrey's company and ours have been developing multiple MOUs with international partners. There is a lot of discussion going on in the international community about what does a post-ISS look like? Is it a bartered system like on ISS where NASA barters the resources away? I don't know how that's going to work based on what NASA's currently said as being basically a 10% customer or investor in the capability, 10 to 20%, depending on how you calculate it. But there is some definite advantages of doing things like that way, because obviously the international partners the international community at times doesn't want to do direct sales into a U.S. Space company. Instead, they would rather be putting money into their own marketplaces. So or their own commercial companies. Will be us working with commercial companies in Europe and Asia and other places. This is all still being sorted out. It's all still being figured out. It's there. If anybody thinks they have the answer right now, they're pretty smart. Because I know we're all, and one of the things I know both Jeff's company and mine is doing is trying to stay as flexible as possible so that we can adapt to whatever model market comes out there. This is not an opinion of Sierra Space, but it's an opinion of Bruce Morse. I think you're going to see some changes in the way, especially in Europe, space is approached. There is a lot, I don't know if the current crisis changes that, but there's a lot of national pent-up energy for having more national projects in space as opposed to just completely ESA projects. I think both will exist, but I think there's a change in that marketplace. And the last part of your question about tourism, absolutely. We're all watching that tourism market because it's one of the evolving markets that's readily understandable in terms of what they want. The barriers to entry are pretty low, actually, because it's basically give them 3 meals and a cot and let them stare out the window. It's much more than that, but it's not as hardware intensive as trying to figure out how to create a microgravity, put up a microgravity glove box or a multi-use glove box or apparatus and all those things that true commercial activities have. So we're all excited about that commercial market. I think that commercial tourism market also connects more people to space. And we're not just talking about tourism in the physical sense. What about virtual tourism? Something that, we've all thought about and try to figure out, can people do virtual TikTok videos on the next commercial space station? I don't know. So, and what about operating things remotely? I think on the lunar surface, this is away from space stations, but on the lunar surface, in the past, you've seen the excitement of scientists being able to operate the Mars rovers. The future that NASA wants to see is more commercial activity of those rovers on the surface, where we get commercial services where people just get to, like they do the Indy experience, where they get in a car and drive a Indy car. Will they want to get in a virtual cockpit and drive a rover on the moon? I don't know. Could be a market. I'll turn it over to you, Jeff.
Okay, thanks, Bruce. I'll take a slightly, I agree with Bruce's comments, but I'll take a different slant a little bit. I'm worried if the future of space exploration is based on tourism, because it ain't why we're doing this. I mean, I love tourism. My boss, Dylan Taylor, went up recently on the New Shepard, Blue Origin, and he said, Jeff, when I undid the shoulder harness and I floated up to those windows and looked down at the blue dot of the Earth, it changed me. And what was he there for? 4 minutes. So I understand the value. And it's way cool, but I don't want our future to be based on tourism. That isn't why we've spent the trillions of dollars. And everything Bruce said is correct. It motivates the public. It's way cool. It does all this. But so, you know, both, all of us working private space stations are looking as well on what's the manufacturing capabilities, what new products can you develop in space to make, as Bruce said, life here on Earth better. So Chris, you know, you'll get your chance to go to space, Chris. I'm sure your salary and bonus will allow that. And, but I'm sorry, that was a cheeky comment. It's important to remember that it's also the taxpayers' money as well. There's a lot of private sector money, you know, supporting these private space stations, and we really do need to show we can make life better here on Earth. On international, it's a major point that worries me. I am extremely concerned that we're entering a period where everyone's going to say one of the lessons from Russia and Ukraine and the decoupling of China from the supply chain is the era, the wonderful era since the end of what you might say the first Cold War, has been this globalization. And I fear it's coming to an end. And whatever I can do to help make international to remain part of space exploration, where it makes prudent sense, where it's appropriate, where it enriches people all over the world, I will do it. And we have to be mindful. We live in a different era today than we did a month ago. But we really do have to make sure, I believe, that we continue on the international path, because I don't want one company, I don't want one nation, I don't want one cultural group going to space and onto the moon and one day to Mars. That's not what I'm about. I'll just speak for myself. So that's it. That's a real big questions, Chris. And if I may repay, Christine, do you have something to say? Because I was going to say I wanted to repay the favor from Chris and ask Chris a question. But go, Kristen, if you have a question.
Well, no, it's, you know,
I mean an answer. Yeah.
The ISS National Lab is taxpayer funded. So while we love the idea of international cooperation, we really lean on our commercial service providers to be able to bring those in. But if it's a designated country, that does cause some issues. Jeff can tell you, because he's managed to get some of those kinds of projects approved. NASA has to approve those going to the station. So there's work to be done on that. But I also think that if we have multiple platforms and they're commercially available, my team won't be needed to be an access point. They'll go directly to Orbital Reef and Voyager and the teams, and be able to make a business-to-business deal. And that's ideal. B2B is where we want to get to here, right? And we don't want to have to go through a government entity to get onto the space station. It will cost more and take too long. It'll go faster, B2B.
Amen to that. May I ask a question of Chris, since we're taking over this, and I worry that we may be focused on stations. I see you nodding, Sarah, and welcome back. My question to you, Chris, is what do you think happens if we can't solve this orbital debris problem over the next 10 years? Can you sort of outline the scenario that you see? What is put at risk? Is anything put at risk and it's just an uncomfortable place? If you could just give the what if we're not successful plan.
I really don't like to think about that. But
I know, that's why I asked.
and none of us should like to think about that. Yeah. That is a you know, at least right now, I don't like to indulge in sky is falling scenarios and everything is going to pot and we're all done and there's no solution. So the threat of an accident in space making orbits unsustainable in like tomorrow, next week, it's unlikely. But as those numbers that I showed you continue to climb, it's not a question of if there's going to be another accident. It's a question of when and how impactful it's going to be. And the answer to that, as more and more satellites are launched and more debris naturally gets generated, because as as satellites get launched, there are going to be some failures. And that's going to be, that's the scariest thing, is when you have failed satellites, or you have upper stage rocket bodies, or you have pieces of debris that can't be moved and then can collide. As that happens, the risk that there's going to be an accident that leads to a Kessler syndrome event. And I think this being the Georgetown Space Initiative, everybody knows what the Kessler syndrome is. I see a few nods out there. But basically the cascading debris event that leads to unsustainable orbits. I don't see how we could viably have things like the space stations that we're talking about in orbit in those cases. You know, you can always go to a bit different orbits. Right now, there's a few crowded orbits, 600 kilometers altitude, 800 kilometers altitude, especially. 400 is where the ISS is. Bruce and Jeff, are you guys at 400 as well, or do you have an altitude yet?
We're still trading. It's really going to depend on what the marketplace drives us.
Okay.
Yeah, same here.
All right. Regardless, it's probably not going to be too much higher than mid-LEO, I would imagine, at least in the near term. But you know, I'll leave that to you guys. But as that's the case, you're looking at a significant amount of debris that's either going to be in, to Jeff's comment, is if there's an accident and we get to this point where it can't be solved, significant amount of debris in an orbit where a human space station is operating, or just say just below one, where debris could come down through that orbit. You're looking at a significant risk. Already the space station is maneuvering, what is it, Christine? Do you know the number? A couple times every 6 months, a couple times a year?
I think it's a couple times a year.
That's what I feel like. I just saw the latest JSC orbital debris newsletter, and it said there were a couple maneuvers recently. As that happens, it's gonna add such a cost to you guys developing your space stations. It's gonna add such a significant cost to anybody who's launching a satellite constellation, that they have to consider what are the mitigation options for protecting against debris. Those options are either going to be to move all the time, constantly moving, to put some kind of, I don't know, protective capability, make the satellites, I mean, I don't even know what it would be to protect it from debris moving at 17,000 miles an hour. What I think it's going to lead to, Jeff, it's going to lead to people not making the choice to go to space. If it gets to that point. Space is hard enough already without a cascading debris event. We all know that. So add in the fact that you have additional, thousands of additional pieces of debris to dodge and avoid. We'll adjust as humanity and just not go. That's what I think is going to happen if we can't solve it. Now, the other side is solving it is mitigating it, understanding where the risks are. Removing the highest risk objects, the ones that are largest, that have the potential to cause the most amount of damage, and keeping an eye on the traffic of what's happening. We're at an inflection point, I think, in space, in the same place that we were with the environment in the 60s, with the terrestrial environment in the 60s. And so at that time, the famous stories in the US where the river's on fire and the skies that you couldn't see because of the pollution. Prior to that, companies would say, well, I can dump my chemical waste here. It's the ocean, it's a river, it's big, it's not going to have a huge impact. Obviously, looking at that now, we'd be aghast at a company doing that, and that would be illegal. We're at that same point in space. Whereas in the past, it was space is big, it's okay, we can leave it, it's not going to have a long-term impact. When we look back 10 years from now on that kind of comment, and we're going to say, well, what do you mean you didn't prepare your satellite to be removed before it launched? how irresponsible were you in that generation? All of you students, when you're talking to your kids and you say, when I was growing up in the space industry, satellites weren't even prepared to be serviced. They're gonna be like, what? It'd be like saying, the cars I had didn't even have seatbelts. Huh? What do you mean? That's crazy. And that's we're at that same kind of analogy right now. So, when all of you are our age, that's how you're going to be referring to this time period, I think.
Thanks.
Wow, it's a really interesting perspective on that. And thank you all for those questions. I'm actually going to direct this question or this panel now to a question from the audience, specifically for Bruce here, but you can all give your input as well. So at Space Vision 2021, a LEO economy was brought up as a developmental vision. Focusing on private efforts, how do you believe we can integrate global teamwork when the rational behavior principle motivates individuals to work towards personal goals? What do you think would be a proper way to promote international cooperation and foster healthy market stimulation? And I'll drop that in the chat as well.
Well, I'm going to invite Jeff to jump in on this question with me too, because he actually has more experience in that world than I do. But so I may be Pollyanna, but I believe corporations that are involved in space have a tendency to have a higher level of corporate responsibility. I think it comes from the fact that we're driven by the mission to explore. And as Jeff talked about, it's not about tourism, it's about science. It's about the things we can do on orbit that'll improve mankind. That said, I think there's going to have to be some adjustments in international policy and international agreements with the people that we partner with to be able to make sure that accountability, whether it's a U.S. and it's an extension of the kind of treaties we have right now. We're going to have to find a way to extend those treaties to also include responsibility of governments to not oversee, but assure compliance of companies that operate from their shores in international space. That's one approach I think that might work. I really do believe, though, that I think space companies, by and far, and Chris is one of those companies that is trying to do, in a commercial way, trying to actually improve life on low Earth orbit because of the challenges we're looking at out there. I think they are a little more aware and understanding of their responsibility to the marketplace, because as Chris talked about, low Earth orbit, in some ways, if you're navigating it, it's a big place. But if you're dumping stuff into low Earth orbit, it's a pretty small community, especially the orbits we all tend to use. So Jeff, you got anything to add to that?
Yeah, I do. Thanks, Bruce. A couple of things. I mean, the basic premise is, it seems to me, to use New York language that's being said here, is people are greedy. Okay, and I echo with Bruce that I think a lot of companies, a lot of entrepreneurs in space got into it for really good reasons, to try and prevent us from being a one planet species, or to clean up the Earth, or a lot of spiritual reasons of the journey. So there's a lot of folks in this community that are really motivated beyond the profit. Two comments on that, though. The first is that one of the fears I have on the current situation, Russia, Ukraine, China being decoupled from the supply chain, is it makes our businesses less efficient. Globalization, the reason automobile parts and your iPhone come from all over the world and stuff, is it's more efficient. And there are political reasons, maybe we will have less globalization, but it will lead to greater inefficiencies. And that will reduce the revenue, which will decrease the margins. It will make it more expensive on some of the things we do. Everything from, if you go out 5 years and this trend continues, your iPhones, your computers, and your personal little piece of the lunar rock will be more expensive. And so I think that people will understand that international partnerships are a way to reduce costs, make it more efficient, get good karma, okay, for a lot of good reasons. And so it's a virtuous circle that comes together. Second comment, if I may, is hopefully not stepping on, even if I am, but hopefully not stepping on Chris or Bruce in any way here. But, you know, I worry about, I don't know how much you guys follow all this, but there's all these companies that are going public via the SPAC route. And you know, I worry about it because you may or may not be aware that first off, you can go public now through this mechanism called SPAC, SPAC, and it has a lot less due diligence than a traditional public offering. So with a SPAC, you can say, as some friends of ours are doing, my revenue last year is 3 million. My revenue this year is 20 million. And in 2 years, my revenue is $1 billion. And no one questions you. And you go public at $10 a share. And what happens? Immediately, the professional investors look at this and your stock price goes down. And a lot of my friends and colleagues and customers, their prices today are at $2.50, $4, $5. Why is that important? Because I worry about two things. I worry that people will get disenchanted with commercial space when you've put, you know, you bought 100 shares in a company at 10 and it goes to 2. You're not a happy person. Okay, you can put it into McDonald's and the stock goes up, or you put it into Google and the stock goes up. You put it into commercial space that's gone through a SPAC and it goes down. So I worry about the public getting upset with this whole concept of commercial space. More professionally, I worry about the government. More and more, what's exciting about this time is the governments of the world are relying on companies like the folks here today and so many others to do the in-space services they used to do themselves. And they want to know we're going to be good stewards. We're going to be there. And if we see a rash of closings, if we see a rash of failures of some of these companies that SPAC'd, I worry the government's going to say, you know what? I don't think this commercial's too good. I needed this company to be there in 5 years, and their stock is at $1. They're being delisted, and now they're being merged, or they're closing the doors. It's my long way of answering that. The question is a good one. I think that if we stay focused on the longer term, we remember why we're in this community. We know that international is more efficient. I think that we can overcome the principal individuals to work towards personal goals, and the industry will emerge far stronger than today. So long answer, but that's what I'm thinking.
Wow, thank you so much for the response. I'd also like to direct it now to a different question from the audience. This one's specifically for Christine. So I will also drop it here in the chat so everyone can read it. Let's see. So one of the main thoughts that I have gravitates toward the role of federal governments in the future of space development. Do you believe that decentralizing the system where we currently view the government as an arbiter would help towards assuring a future that does not push us towards dystopia? That's for Christine.
I hope we're not going towards dystopia. And I like the gravitates comment. I see what you did there. I think there's a role for governments, and I think this was mentioned, I think Bruce mentioned, you know, in making some rules. They've done this for centuries, right? There were rules about being on the sea and maritime law, right? There's going to be more rules and regulations, and governments are going to have to agree to that. But then from the standpoint of making things work, I think it's up to private businesses and commercial entities to go in there and work. Because if it's just government funding, we're not going to get very far. Governments will run out of money and we'll have other focus areas. And so we need to make this something where there's a commercial application and companies, like all of the companies here, can make money. And when that happens, then there's going to be a lot more opportunity. And again, I hope it doesn't push towards dystopia. But if all it is a place that's a platform for the Department of Defense, we're in a different universe than we are if there's commercial product going on. And then that commercial product that's happening, whether it's drug discovery or 3D printing or whatever's going on up there, will be defense defended because that's income, it's revenue, it's gross domestic product, right? Well, and we need that, so it will be defended because it's monetary. I hope that answered. Jeff, Bruce, Chris, feel free to jump in here.
I'm curious as to the question, the alternative. So the decentralizing the role of this decentralized system. I mean, are we talking like, is this like a blockchain type of concept that is being proposed by the questioner, or what's I just wonder what the alternative to governments working together to have a role in regulation in orbit, what the alternative might be. That's a legitimate question. If either the panelists or the
anarchy. I'm all for anarchy.
Who asked the question, I suppose, feel free to unmute yourself, whoever asked that question, and I guess explain the question.
And if anyone else has thought on it too, I mean.
All right.
I'll make a general statement that's doesn't go to the heart of the question, Chris, and folks may not know, you spent many years in Japan and you're a student of understanding the Japanese society. So you may very well, I hope, agree with what I'm about to say. Of course, there's a role for government. What's happening in the United States is that role is changing. And I do always want to make clear that, I speak as an American, and my thoughts on how you change the role of government in society and in space exploration are from an American perspective, only from America. And in Japan, they do exploration differently. In Europe, they do exploration differently. In Asia, in the Middle East. So when we talk about, the future of space development and decentralizing the system, that's really an American perspective. In many societies, they do commercial markets far more centralized than we do in the United States. So I just want us to be aware, or you, especially the students of Georgetown, that you have to be careful because space is so international. And remember, you're coming at it from your American perspective of what is the ideal relationship between government and the business. And that isn't echoed always throughout the rest of the world. So
I think that's such a great point. And I imagine, knowing Georgetown, having gone there and knowing the students there, I imagine there is an international mindset to many of the students. But I would wholly agree with Jeff's point. And on the broader scale, it just serves to encourage everyone to get out there and think from other countries' perspectives. And this actually fits both of the questions that Sarah dropped in the chat. How do we promote a healthy international cooperation and market stimulation? What should be the paradigm for monitoring orbital activities going forward? Both of those speak directly to the need to work with, to understand, to see a situation from the perspectives of a different culture and a different country. So I think that's a great answer, Jeff, and I think that's a really good point.
I want to just add something to it. Before I joined Sierra Space, I worked at RUAG, which is a Swiss international company owned by the Swiss government, but with manufacturing and commercial sites all over Europe and also in the US. Very different approach to a government-owned business. They were not involved in the business. They essentially looked at their role as being an investor. You had the responsibility of any company that was headquartered in Switzerland to follow the Swiss law, but they didn't get involved in the day-to-day activities. They didn't leverage items down on or specifications down on us or oversight down on us. They simply said, look, we've invested. You better make darn sure you're making money that is an ROI back to us as the Swiss government that would be equitable to what we could get in another investment. That's a very different, as Jeff said, that's a very different approach to government engagement in business than you see in the US. So yeah,
money's involved, and that's a good thing, right? So if you're making money and that's a part of the gross domestic product and having income, that makes a stronger case than the government's just putting money into that. platform.
Great. All right. And we have another question here. So in addition to our Georgetown students here today from GUSI, we have certain students from the other SEDS chapters, and this student is from one of those schools. So it's for Jeffrey. So as an aerospace engineering student at Ohio Space, I am very interested in Nanoracks work on Starlab. Can you elaborate at all on the roles of OSU and other universities on this station?
Look, here it comes. Go for it, Bruce. Wait,
Bruce is getting into action.
Bruce needs a back.
Here we go. Should we all do the cheer?
I'll let John know. I'll let John Horak know. So I didn't touch on it in my presentation, but one of the core parts of Starlab is our George Washington Carver Science Park. And all of us in the different teams are involving as many universities as we can because we believe in it. It's the right thing to do. But speaking for Starlab, what we see is that the core of the business model is a science park, and Ohio State will be one of the gatekeepers for that. And so we're delighted to have Ohio State. We're delighted to have USRA, two really great organizations with a lot of expertise in this. And so part of the functions of Ohio State, of USRA, will be to help run the research portion of what we're doing, and maybe in the future, the manufacturing. One of the takeaways that I have, having worked more than a decade on the International Space Station, is that a lot of us folks in the space world, we're not very good at operating things that are not, hardware driven, not involving things like launch vehicles or building a space station. And so we want to turn over as much as we can to people that have experience in taking projects from research and developing them for greater research or manufacturing. So Ohio State is a very important player with us. They'll be one of the gatekeepers to utilization on our platform. So that's that. Sarah, back to you.
Sure. Yeah, to expand on that question as well. So why is it such a good time now to enter the space industry? And for the students in our audience, what should they do to prepare for such a career?
I'll kick that off. There's every kind of job needed in aerospace. And I know when I talk to students a lot, there's a lot of STEM, like we need to have engineers, and we do. And we need to have lots of scientists doing that. But we need marketing people. And we need writers, and we need people who can communicate the story. We need business development people. So in my view, whatever it is that you do, whether you're in communications or you're a scientist or an engineer, there's that role in aerospace, and more opening up every day. I think it's a great time to look to a career in aerospace in whatever thing it is that you do. In my case, look, I'm an MBA. And other people here are business development people. So everybody isn't necessarily a scientist, but there's roles for all of those as we build this community.
I'll grab it next if you don't mind, Chris. This is a passion of mine because I really am excited about the students entering this time, because I believe you're in the heart of another renaissance. As Jeff talked about, space started as a domain completely owned by the government and for the government's interests. We saw a little bit of renaissance in communications and weather, but then it kind of stopped and was back to the government really managing everything else that happened in space. At the end of the shuttle era and at the beginning of the commercial launch era, companies like SpaceX completely changed the way that we access space by finding ways to get, and others, finding ways to get low cost access to space. That was a major shift in removing a major hurdle to open up what we're talking about here is commercialization of low Earth orbit. Now we've entered this era that government is approaching. I mean, they still have incredibly responsible things they have to do in low Earth or in space, but government is approaching space, especially in low Earth orbit, as a services market now, where they can look to the to industry to to provide them the capabilities. And I think, as Jess talked about, and as Chris has talked about, that's a very efficient way to really expand the activity with global commercialization. So you're in the middle of a renaissance. What can you do to prepare? As Christine has said, there's a ton of different of capabilities we need to make this marketplace grow. Definitely, if you're on the technical side, learn the business side of the world. If you're on the business side, learn the technical side of the world. Because one of the things you're going to find on your journey is what you think your path looks like today has absolutely nothing to do with the journey you're going to look back on. You're going to take on roles, you're going to change jobs, you're going to change functions. And every time you do, you're going to learn something new and something exciting. And the market you're in, the world you're in, is going to change around you. Space policy is going to change. The role of government and the role of commercial is changing. The role of the international, hopefully, is changing in the right direction. I let Jeff worry that this is what we're seeing in Europe right now could be a stymie to global commercialization. But learn, never stop the learning process. Recognize that out of every job, you need to learn something from it. Get that and get it as you're preparing for that next step in your career path. And don't be surprised if you sit in your desk one day and know what your job is, and you look up and go, what am I going to do next? And you don't know the answer. That's the best part of where you're at. The whole world is changing around you, and it's really an exciting time for you. Sorry, long-winded.
Love the answer though, Bruce. And man, I totally agree. I mean, it's such an exciting time to be getting into this. 15 years ago, you wouldn't have had these kind of opportunities. You wouldn't have had a panel like this. And it was thanks to the revolutionaries, one of whom is on this panel right now, Jeff Manber, who helped change the way we see commercial space. So you're lucky to be hearing from him, not to get his head too big if it's blowing up on the screen, but truly changed the way we see space. And there's others, throughout the last 2 decades who have done that. And because of these trailblazers and groundbreaking individuals and technology advancements, we're where we are today, where you all will be graduating in, between the next 1 to 3 years. And you'll have these opportunities. So, what do you want to do? Do you want to do human exploration in LEO? Yeah, there's opportunities for you to work on that. You want to do commercial satellite constellations? Yep, you can work on that. You want to do deep space exploration? You can do that. You want to do something like JWST or the next generation space telescopes? There's opportunities for you to work on that. And as Christine said, not just in the technical side, but across the board. So I don't know, why is this an exciting time to be in space? It's the best time that there's ever been to be in the space industry. 5 years from now, it might be even better. But right now is the best time it's ever been.
Yeah, I'll follow through, and thanks for the nice words, Chris. But what was the revolution? And because Chris and Bruce and Christine, I don't know you, but as you probably know, it's so obvious to us. Let me say what that revolution was that we worked on a decade and a half ago. Let's say we go back to the Apollo program. Lots of jobs during the Apollo program. They needed lots of people. It was one program, one vehicle, handful of companies. You couldn't go in and say, wait a second, going to the moon's real cool, but I worry about this, and hey, I'd like to do this. It wasn't a normal industry. And all of you take that for granted, and that's what we changed. What we changed was you have the ability today to say, hey, this Artemis program is pretty cool, but you know what? I'm not really interested in that. I'm a green kind of person, and I want to look at orbital debris. And you know what? There's a company and there's companies that are involved in that. Or I want to get involved in private destinations. I want to get involved in big data. Why is that, our weather forecasting still coming from the government? Wait, now there's companies saying, let's privatize the weather forecasting. Gosh, you take anything that you want to do now that's space dependent. And now there's opportunities. And if you, the best of all, from my perspective, and here I'm showing my DNA here, maybe you'll find something overlooked and say, wait, I can start my own company. And there'll be people now who give you 100 grand to just see how you do. Be careful, don't take the money just because it's money, but that's another panel, okay? The money you take is very, very important because that's like moving in with somebody, okay? That's a whole different trip. But you can raise 100 grand like that now. And then the next step goes, there's venture capitalists, there's hedge funds, there's private equity funds. And so it's a glorious time in that regard because it's a normal marketplace. The other thing that makes it so cool that we didn't have in the, let's say, the Apollo program, in the Apollo program, our heroes were the astronauts, and deservedly so. Okay, brave, all men, brave men risking their lives to go to the moon. I mean, dang. Today, our heroes are these like weird people like Elon Musk and you probably know Bob Bigelow and these guys who they have money and they're risking it and they're doing these things, and it's more like going back to aviation where you had Howard Hughes and you had leaders of Grumman and Pan Am and other airlines. So it's a cool time in that you have your choice. You can work for a company, you can create your own company, and there are heroes. So that was the revolution.
Those are really great words to hear. And I want to thank everyone again. I'm seeing we're getting close to 6:30 here, which is our end time. It's been an honor hosting all the panels. So thank you so much, Christine, Chris, Bruce, and Jeffrey. You've been amazing. We've loved hearing all of your perspectives on these questions. And thank you for answering the audience questions as well. Thank you also, shout out to Andres for picking up there when I dropped off the call for a little bit. Thank you for the questions. And everyone, and also here I'll drop in the chat. If you'd like to hear more about opportunities such as this one, feel free to follow Georgetown NASA DC Space Grant on Instagram. That's where I post updates and NASA opportunities. So stay tuned. And thank you again. Thank you so much for attending this event. Hope you have a great evening.